reality. And what we want to recover at a higher level is indeed space-time. You cannot use spatiotemporal notions to explain this notion of emergence. So, I mean, here I pictured it here, the quantum gravity states, which are not fully spatiotemporal and relativistic space-time. And here there's this arrow which should represent emergence, but it's not like, you know, a temporally directed arrow, simply because emergence is not a physical process. Now, what about our metaphysics of laws, and in particular the role of space-time within our metaphysics of laws? So just to be clear, now I'm just going to focus very generally on Humean accounts of laws and non-Humean accounts of laws. I know that there are like lots of varieties, but let's just say I'm just going to focus on like mainstream positions here. So let's start with the Humean accounts of laws, and let's ask, okay, what's the role of space-time in this framework? Here is the super famous quote by Lewis, who said, "All there is to the world is a vast mosaic of local matters of fact. All else supervenes on that." There's also another very famous quote by Lewis, in which he says, all there is to the world is like one little thing after another. So there is really this notion of locality, contingency, adjacency, this idea that you can say, okay, I have one thing here, and here the next one, and the next one, and the next one. So there's really this notion of locality that is used to describe what the mosaic is. And a definition of the mosaic is important because it's from it forms the basic for the supervenience relation that obtains between the mosaic and the laws. So this localizability, it's really present, at least in Lewis's formulation of humanism, to say what the mosaic is, so to define the mosaic. And then we have non-Humean accounts of laws in which laws are understood as primitives. And in general, like if you look, for instance, at Maudlin's formulation of primitivism, you always have also this primitive arrow of time that directs the action of the laws. So, for instance, Maudlin always insists in saying that, like, you have in his ontology, you have the state of the world. You have the laws that act on the state of the world, and these laws produce later states. So yeah, you need a primitive arrow of time. And by the way, not only in Maudlin's primitivism, you have this conception of production also in other non-Humean accounts, as like in dispositionalism, because the disposition usually act toward a certain direction. So both accounts, so Humean and non-Humean accounts, use some spatiotemporal notions to define either the mosaic in the Humean version, or to define the action of the laws on the mosaic. So the puzzle then is that if metaphysical accounts of laws rely to some extent on space-time, then you come up with some issues with quantum gravity. And well, this is one of the papers that have been published in like the reason about this tension. And they say quantum gravity's suggestion that space-time may be emergent and so only exists contingently would force a radical reconception of extant analysis of laws of nature. So the issue here is that if we have some metaphysical accounts of laws that rely on spacetime, and in quantum gravity, spacetime is derivative, meaning spacetime is non-fundamental, there is no way to actually implement metaphysical views of laws to account for quantum gravity laws. So it looks like our metaphysics is not, let's say, good enough to account for the laws that should govern, that should apply to quantum gravity. And this is a problem because arguably quantum gravity, even though it's not a complete program, but it's still part of physics. So arguably there are going to be laws in there. And so how should we account for them? There are two options that have been stated in the literature. So one is simply to say, okay, maybe there are no quantum gravity laws, so maybe like the give up option. We actually have no laws of quantum gravity, and laws are simply maybe emergent entities. The second option, which I think is a more serious one and more promising one, is simply to update our metaphysics of laws. I mean, in the end, metaphysics should take lessons from physics. So if physics says that our accounts of laws are insufficient to account for quantum gravity, maybe we should update our metaphysics and come up with more promising options to account for quantum gravity. Both these options have been stated in the literature. This one, so the second one, has been more thoroughly defended. This one has only been actually stated but not defended in the literature. So now the plan is like to see, first of all, to see like in what sense laws might be understood as emergent, and then add some suggestions to update our metaphysics of laws. So we're going to investigate those 2 points in turn. So let's start with the first option, so the give up option. And trying to understand like in which sense laws might be emergent. So Lam and Oriti, they write, if the notion of laws does indeed require spacetime, and if the latter is emergent, then so are the laws. So the idea here is that at the bottom level, you have quantum gravity, non-spatiotemporal decrees, which are also non-lawful. So no laws here. Here at the emergent level, you have relativistic spacetime together with laws of nature, which are supposed to emerge together with spacetime from the quantum gravity configurations. Now, they don't defend this position, they just state it. And what they write is that they reach this conclusion by way of sort of logical argument. So they say, again, laws of nature rely on spacetime. There is no spacetime in quantum gravity. Maybe laws are emergent in the same sense as spacetime is emergent. And they write, if the notion of laws does indeed require spacetime, and if the latter is emergent, then so are the laws. Thus, there are simply no laws at the fundamental quantum gravity level. There are no laws of quantum gravity. This is logically straightforward, and we have no in-principle objections against this position. I'm not sure about, like, I don't think that this is logically straightforward to take the laws as emergent if space-time is emergent. So I think that there is, the problem here is with this first premise in the reasoning. But we might buy this for the time being and say, okay, let's buy this position, let's be charitable. Indeed, we accepted the idea that space-time might be emergent. Why shouldn't we do the same things with laws of nature? In this sense, laws would still exist, but just not at the most fundamental level of reality. I mean, in the end, quantum gravity, it's pretty weird. Maybe it's not going to include laws in it. So this is the picture that we are buying. But the problem, well, one of the problems with this view is that when people have argued that here there is no space-time, they could actually give some reasons to think why here we have no relativistic space-time. Because the features that we have here, the way we describe physics at this level of reality, are nothing similar to the way we, I don't know, calculate the distance or the angles or whatever within GR. And if we want to accept that laws are simply not there at the quantum gravity level, we should demonstrate, we should really show that the concept of lawhood does not apply in quantum gravity. And I don't think that this procedure can go through simply because there have been so there are equations in quantum gravity that describe what things like what happens at that level. And then one might say, okay, but not all equations are laws of nature. Sure. But then that's one of the reasons why maybe we should really think to update our metaphysics. Another reason I think we should be skeptical of this account of taking laws as emergent is that now we need to explain how laws emerge from these non-lawful degrees of freedom. In the same way that we have explained space-time emergence. And my question is, okay, how can we do that? We might apply functionalism to the laws, but that, yeah, I have no idea how that might work. I don't know if you're familiar with functionalism, but it's like an approach that has been applied to space-time emergence, like just plain space-time emergence, and it simply takes the spatiotemporal states as defined for what they do rather than what they are made of. But yeah, I have no idea how this might work with the laws. And the other thing is that usually laws of nature are an explanatory tool in scientific practice. And indeed, we might need laws to explain how space-time emerges from the quantum gravity level. But if we need laws to explain space-time emergence, how are we going to do that if there are no laws in quantum gravity? And from the physics side, where we really need quantum gravity laws in particular is when we do limiting procedures. Limiting procedures, which is when we recover relativistic spacetime, it's like a map between the quantum gravity laws and solution of GR. So you have a map between laws of two different theories, but again, you need some laws to start with. Otherwise, you're not going to be able to do that. So that's how we arrive at the second option I was describing before. If laws are needed to explain how space-time emerges from quantum gravity, we better find a way to update our traditional metaphysics of laws. Otherwise, we simply give up. But I don't think that's a nice option to have. There are some attempts in the literature to do that. These attempts have tried to update the mosaic in the case of Humean accounts, and they have tried to get rid of this fundamental primitive direction of time in non-Humean accounts. Little importance has been given to approaches of laws as constraints, which is like a recent position that has been employed within physics. Very briefly, laws as constraints. So to take laws as constraints means to understand the world in such way that it cannot be incompatible with the laws. So it's a view very similar to like what we take mathematics or logic to be, right? So the world cannot be in such a way that it could contradict the laws of mathematics or the laws of logic. And it's a very general account of laws. It can really be applied to many different scenarios and frameworks. But remember, we wanted to have an account of laws, or at least it would be beautiful to have an account of laws in which laws are able to actually explain what's going on, what they describe. And I'm just a little bit worried that constraints might not explain, or maybe you have like a too weak notion of explanation that is attached to constraints. So I don't know. This is a very much work in progress, and I don't know what to think about constraints laws in quantum gravity. It's surely a viable option in the sense that constraint laws do not employ spatiotemporal notions to be implemented, but we lose a little bit our explanatory power of laws. So yeah, that was it. Thanks.
So let's start with Jonas. No, but you were not the first this time. So Jonas, up and at the end. Oh, okay.
Hello,
Jonas.
Yeah, thank you very much. So I have a very naive and probably very biased question, but I didn't quite understand why dispositions didn't work at this fundamental level.
So the problem with that would be that so as I understand these positions, like they work in a certain direction, right? You have this notion of production also in the dispositionalist framework. Like if the window is fragile and I throw a rock to it, the breaking of the window is going to happen at a later time with respect to my throwing the rock. So you have this implicit notion of production and directionality in the account. So it's a little bit weird to implement it in a framework where you can really when you don't have this asymmetry. One thing that I didn't mention, when you calculate like transition amplitudes in quantum gravity, like usually in the usual framework of quantum mechanics, you have like your initial state and your final state. But in quantum gravity, these are just labels. They don't really mark an initial and a final state. These are just really labeled with no no temporal connotation, and more importantly, there is no asymmetry in the framework. So that's the problem with this positionalism.
Okay.
Thank you very much. There's one bit I didn't quite get, so I was wondering whether you could perhaps say a little bit more about it. So we have this view, discussing this view on which laws emerge together with space-time. And then he said something that went by quickly, that suggests in order to explain how emergence works, we need to have this map between these different kind of laws, the quantum gravity laws, and then the GR laws. And I wonder whether that's really true, that we need to have an account of law on both of these levels. Wouldn't it be enough for emergence to have something, an account of a classical limit which takes quantum gravity, and then we have general relativity, and we just looked at solutions to the equations of motion, so it's models of the theory. And we have no, you can do GR without ever bothering about the metaphysics of laws, right? That's what every physicist does. So isn't it enough to have some sort of, for a theory of emergence, some way of mapping suitable models of quantum gravity and having an approximate a model of general relativity, and we can do that without having a kind of law. Just we have these two theories.
Yeah, that's true. Physicists don't need metaphysics to do their job. Clearly. But and of course, like the fact that people, where was this? Like, no, okay, let's take it. And of course, the fact that you have equations, it's not enough to say I have an equation, then that equation is a law. There are plenty of equations in physics that work amazingly to compute whatever, but they're not laws of nature. So my worry, maybe it's a silly one, but as metaphysicians or as philosophers, it would be weird to say physicists calculate the limit of quantum gravity, the classical limit of quantum gravity, but we have no way to say whether we have laws or whether there are laws at the bottom level. We might be agnostic. Maybe, I liked Fabio Bueno's talk this morning. I'm sympathetic with that option, but it's if we take quantum gravity to be a physics enterprise, as philosophers, it would be nice to say there is a way to account for quantum gravity laws.
Yeah, it sounds a little bit like it's a philosopher's problem. So here I'm the guy with quantum gravity, and you come here, you're a philosopher. He said, well, where are my laws? Well, I can give them to you on religion, but since I don't care about laws as much as you do, I might not have anything interesting to say about the fundamental level, but you could they come back out of my picture, and you could have them if you really want as a philosopher. I would go like that.
There's something on your left here, no? No? Okay.
Yes, do you want to go first? No, please.
No, don't let that answer.
Questions for Mike?
There's you after him. If we have time, so.
Thank you for this talk. It's really interesting and really clear. I was wondering what's wrong with functionalism about laws?
How would you apply it to the laws? Like, how can you say, so the way functionalism has been applied to space-time is a bit, so people have said, okay, there are some functional roles that I can individuate, and those roles don't need full-fledged space-time to be there. I can be counted with like some approximate form of space-time to still have those functional roles. I'm not sure that this approximate notion that you find, like, some these approximate roles in maybe your fundamental level can be applied to laws. I mean, either laws can come, like you have the real law, so the law, which is analogous to having real space-time. And then you have the laws roles. What are the laws roles which are not laws? From which laws have to emerge? That's my puzzle, but that's why.
Have you?
Yeah, I was intrigued by the alternative of biting the bullet and say, look, just there are no laws, right? And then you say, well, that's not enough, right? We need then to tell some more of the story. And I thought that the whole point of saying, look, there just are no laws, if you take that seriously, you would say, well, then there are no laws. So it's not that there is some extra thing that needs to actually to be accounted for, right? And, so I wonder if the view shouldn't just say, yeah, we just don't have those things. Of course, if you want to develop a different account of laws, then you do something else. But given if laws depend on space-time, and we don't have space-time, well, then there's no law, there's no space for even laws emerging in some sense.
Yeah.
Why do you think that that's not enough?
I mean, that is an option. It's not that it's not an option. You might, I mean, I don't think, again, if you ask a physicist, okay, what's your favorite account of laws? Like, you will receive like no answer, I guess.
Rightly so. Maybe there are no
Maybe
laws.
there are no laws. I was sympathetic with your view this morning, but I hadn't like I didn't know we could be agnostic, but
Take a look at von Franzen's laws and symmetry.
Sure. Thanks. So I guess this is maybe can be a follow-up to Russell's question about functionalism. So I'm kind of thinking about what functionalism might be. I thought about this a little bit in one of the more non-Humean case, maybe less in the Humean case. But in each case, it would kind of rely on finding something in the vicinity of space-time relations to use instead. So like instead of like systematizing the distribution of properties over space-time, we will like systematize the distribution of properties over some other fundamental external relation, whatever that might be, and assume that we have one. And whatever maybe the state spaces are kind of built up from in quantum gravity, we try and use that instead of space and time. And then in the Humean approach, just like systematize that. And then the non-Humean approach, maybe look for something like a kind of causal ordering, even if it's not like one that lines up with a temporal ordering. Maybe we can still like identify causality in this quantum gravity picture, and then laws would be kind of whatever generates the world along that causal ordering, even if it's not a temporal ordering. So the general strategy is kind of find some near relative of space and time which is still there, and then kind of do with respect to that relative whatever we did with respect to space-time before.
yeah, okay, sure, yeah. I guess, yeah, you could do that, especially like causal set theory, that's pretty straightforward. And maybe even maybe also within loop quantum, right? But one really has, to look precisely at what's going on there. But yeah, that might be a way to go. Definitely, yeah, thanks.
Gavita, short one?
Very short. 3 alternatives to that. Very, very short. So, one, you could have a disjunctive account where you have some laws that are what Maudlin calls laws of temporal evolution, and those have to be spatiotemporal, but then you could have some other kinds of laws that don't have to be laws of temporal evolution. Or you could have a deeper modal structure that contains laws as one of the modal features it contains, but that's not the only thing it contains. And the way in which the space-time emerges has some modal features as well, but that can't be expressed in terms of laws. Third one, you have the laws all along, but so they don't emerge, but they only actually apply when there is space-time.
Sorry, they only actually apply?
They only actually apply whenever you have space-time. It's not that the laws themselves emerge, but because they are spatiotemporal, they only apply to things that are actually spatiotemporal. So they exist all along and they are part of the furniture of the universe, but they only apply inside space-time.
Yeah, but so that would be a little bit weird in some contexts. I'm thinking about like if you need space-time for there to be laws. I mean, sure, you can imagine scenarios where there's always space-time. So there you go. You have your laws. But that's not the case. Well, with like if we, I mean, of course, one of the premises was that. I mean, the option was like, okay, let's see what does it mean that laws might emerge. Of course, if you take that laws do not emerge, then they are always there, and actually you might even have the scenario in which you have no space-time, but you have like all the laws that physics needs, and once you get space-time, maybe they get activated or they start like acting on whatever configuration you have. Yeah, of course.
Plato would be very
Yeah.
happy. Thank you again.